Recording in progress.
Yeah. So today we'll discuss about the RAG, Retrieval Augmented Generation. Okay, RAG. In every LLM, in every company, if you are building any LLM, okay, you're building any LLM, you're deploying any LLM, your LLM is a domain specific LLM. It is not like the global one. Okay, it will be the domain specific one. Domain specific in the sense your LLM, you're developing it for your bank, your customer Q&A. Maybe you are developing it for your legal document. Okay, legal document analyzation. Legal document analyzation. So whatever your LLM is a domain specific, it's company specific, right? That's why your LLM need a correct context in order to give you the data. In order to answer your question, it needed. See, example, today I have LLM deployed, means trained and deployed. When you train and deploy, you ask something to it. Okay, you ask something to it. It will only answer on what it has trained, the data which is available, on what it has trained, on what it has trained only. So that's why whenever you see you are asking ChatGPT about something, then it will say that I'm only trained up to 2025 or 2024. So it is not having a context of what happening today. So this is a case with the ChatGPT before, like in 2 years back and 1.5 year back. If you see, this is a case with ChatGPT. It will say that I'm only trained up to 2024 only. And even though you ask anything, it is used to print 2024 only because it got trained up to that only. Okay, see, your LLM is out of data, out of uh, context, like it is not at the right at the moment. What happening right at the moment, it is not. See, any LLM if you are deploying in your company's portal, a company has to, this LLM has to work according to your company's data. So it is not like everything I will be going to give to my LLM, or it is not like all the data, the latest data, I'll be keeping it for training. So every day I will do training, then I will deploy. Every day I will deploy. No, every day you will not do train, every day you will not deploy. Instead, what you will do, your LLM is here. This is your LLM. You have two ways. One is coming from the user side. Okay, the user who is going to ask the question to your LLM from front end and back end, and you will be having a pipeline. You will be having a pipeline here to update the data. To update the data. So where you will update this data? By using this pipeline into your DB. Which DB? Which DB you will going to, you're going to do in vector DB. Okay, so this is the pipeline. So this pipeline will be doing some work. Okay, I'll tell you this very clearly. In real time, what happened? So this is a vector DB. Chroma, okay, psi and Viviate, Quadrant, Milius, PG vector, like this different vector DBs available in the market, cloud and self-hosted both. It's up to you which one you want to use. Okay, so PG vector also good and Milius also good because CNC have supported one. You can use them. This is my LLM. This is part of my building and deploying. Okay, the life cycle we already learned, right? The life cycle we already learned is in this. This is a separate line. I'm telling this separate line. I'll draw one more line here. This is a separate line, separate pipeline, which we will be going to build and deploy. Okay. So this is a separate pipeline. From where, sir? So this one. So where are we planning to deploy? This LLM is, it's up to you. Like you wanna deploy into EC2 instances.
I don't see it hasn't
You wanna
changed
deploy into the ECS. Please go on mute, sir.
Have you noticed a change?
Yeah. You wanna deploy in EKS or you wanna deploy in cluster of VM servers. This LLM here we will deploy. Is it instances, ECS, EKS, or a cluster of VM servers? EKS means any Kubernetes. Your Kubernetes, AKS, EKS, ZKE, whatever. Here you will be deploying this LLM. And we have most of the cases, we will go for the Kubernetes service only for the LLM because we need to handle scalability, high availability, okay, the reliability. When we talk these kind of words, Kubernetes is a matter to deploy. And to deploy this, the end. So in our LLM lifecycle, we already discussed. To deploy in the end, what we will be using? We'll be using like VLLM, Triton, or TGI, or PyTorch. Okay, PyTorch is not for the production grade one. It is the local development one only. We'll be not using PyTorch over the over the production level. So because it's having a problem. So in our class, we are going to deploy in the Kubernetes. Okay. See it here. This is an LLM. This is a user. Once we deploy here, this LLM need a latest data. So this data, it will go and find it from here. It will go and find it from here. This will analyze it and it will come to you with a nice briefed answer. The context will be going to take from the your vector DB. The context will take from your vector DB. It will do a hybrid kind of things. It will do an hybrid rags. Most of the cases hybrid only. So keyword and vector similarity. So that will be going to work in this vector DB. So example, I would say I have different data sources. I have different data sources. Okay. So these are all text or these are all something. maybe images, videos, tickets, these are all files, PDF files. So what you will be doing, all this you will load, you will collect and you will decide, you will analyze, is this data is enough to me? Yes, then by using this pipeline, what you will do, you will convert them, load and you will convert them into the embeddings. Okay, so embeddings and then into vectors. Store them into the vectors. You're going to store them into the vectors. So here, in order to give a context to your LLM, there is a chunking process will be there. Okay, there's a chunking process will be there. So it is not like all the files at one go, 10 files I'll give it to it. When you give 10 files directly, it's not able to process. There will be a precision will be lost, degraded. Okay, so your context will be heavy and the quality of your response will be lost. So it will be uh, confused. So it is not like a book, a big bundle of book I given to you, you read it. No, you will divide them in a chapter wise, right? Chapter wise dividing is called chunks. Chapter wise dividing called chunks. So this chunking we will be going to decide what size according to the use case. According to the use case in the sense, if I'm building any Q&A chatbot, what size I need to maintain? 100, 0 to 100, 300, 100 to 300, or maybe 500, 1000, like this. What chunk size I have to maintain? This is you're going to define over your experiment only, sir. This chunks. Okay. So this is a separate pipeline. This pipeline will do. What it will do? It will take, load, converts vectors, and then it will keep into your vector DB. Okay. So whenever your user is asking question, the context will be created from this vector to your LLM, so that the LLM will be understanding and giving you the correct answer by using what, sir? This is all called RAG. It's all called RAG. All called RAG. This is a RAG, sir. It's a very popular. Every LLM is using this, and this is your work. If you are going to work on any chatbot or any LLM in your company, this is your work. You will be going to contribute actively on this. So I have made a notes here. So RAG is just nothing but something engineering they have done. It is just searching your document only. There is some problem with the GPT when the things are going on. Because of that, the RAG solution we got implemented into it to bridge the gap, to bring up the gap and fill it. So we have different RAG types actually. We have Navier bias RAG only, contextual conversational RAG, and hybrid RAG. So like this we have 4, 5, 6, 8 RAG systems we have actually. The life cycle of the RAG is we will do ingestion with a pipeline. That means in your real-time world, you might be collecting the data, conference pages, Jira tickets, Slack threads, GitHub repos, wikis, PDF, runbooks, everything you will collect them and you convert into them into embeddings. Okay, you convert them into the embeddings. So for that you can use this unstructured.io. It's a website actually. Enterprise companies are using this to make ready a data for your generative AI systems. And which is one more thing, LDAMA disk, which is also a loader, and custom script. Custom script is nothing but our pipeline only. We will chunk the documents, like if I am using GPT 128K, if I'm using cloud, I will use 200K, like that. If it is your custom thing, it's up to you. You have to do an experiment on it. You cannot directly dump everything into the LLM context. So that is a problem. If you do that, you will lose the response quality. Okay. So there are different method of chunking strategies. Recursive, character splitting, you can do with the LangGraph also, this same thing. And semantic chunking. So we would be having some sort of scoring over there, and document structure aware. So here we use only headings, sections, code blocks, natural boundaries. These two are most of the time we will be using, and we'll use chunk size 500, 1000, 700, 300, like this, with some overlap. Overlap means, uh, see it, this is a paragraph, okay? This is a paragraph. This paragraph, when it is loading to my context, to my LLM, I can't give this entire at one go. I wanted to divide them. I wanted to divide them. So when I wanted to divide them, how I will be divide? This is a one line I would like to divide because there is a full stop. And second, this is a one more line I would like to divide. So this is a one chunk and this is a one chunk. So the number of tokens are very less and the process also less. Your cost also you are saving. All this applies to your cost. Okay. Okay, I'm giving this one. I'm giving the next one. Sometimes there might be a loss of losing this you cannot. Between these two lines, I might be use this last word 200K. This last word. So because of this, this is a main word, then our LLM will understand something else if you miss this one. So if there are 10 numbers in first line, in the second line 10 numbers are there, then we are loading second line from 8 number from the first line. 1 2 3 4 5 6 8. Second one also, 11 12 13 14 15 16, like this. Okay, here 10 9 and 10, 9 and 10. I'm loading this as a one chunk. I'm loading this as a one chunk. All this as a one chunk only, as a one go, one go. So when I'm loading this, maybe I might lose this. I might not get this two words. So that's why what I will be doing, I'll load this one also. Also I will load 9 and 10 in the second chunk. Overlapping. Overlap words at least 50 size, okay? So that my LLM will never lose this. Even though it is duplicated, okay, fine, but we are giving this overlapping things. So this is what we will maintain in the chunking. Here you can see, if a key fact, two chunks overlap, ensure at least one chunk has a complete fact without overlap. You can maintain this overlap at least 50. At least 50. That's enough. One more thing, embed the chunks. Whatever the data I'm loading in a chunk wise, I can use these things, cosine, similarity, or whatever. So OpenAI text embedding Stilog I can use. Cohere embedding v3 I can use. BGE I can use. All mini I can use. This is the smallest one, which is very good. Your data science engineers most of the time you will be using. Other than we use this one, or you can use this three. It's okay, production grade things only. If you are going with multi-language like Telugu, Hindi, English, Kannada, some different languages, this is the best one for your tokens. And vector databases, once we convert all the chunks into embeddings, we are going to store them into the vector databases like Pinecone, VV8, Quadrant, this one, okay, like this. And one more thing, retrieval pipeline. Retrieval pipeline. Whenever the request is going and hitting the RAG, how this retrieval will be happened? Online, offline. This is online one. Online means when a request hitting to the RAG. So it is going to calculate the similarity. It is going to calculate the similarity and keyword. Both things it will do. Keyword and similarity. By calculating that, it will do re-ranking again one more time. Once it will do re-ranking based on that score. So that will be the final answer for your query. That will be the final answer for your query. So if you go through this document, I have mentioned each and everything. I will just directly tell you with this diagrammatically so that you will more understand instead of that document each line by line teaching you. I was saying that LLM build and deploy we will be doing, and for our RAG we will be having a separate pipeline. So this is a separate pipeline which I'm talking right now. Loading this data, convert into embeddings, load into the chunks, and then keeping into your vector DB. Keeping into your vector DB. And use your LLM to answer that. So there is one more thing called hashing. Okay, cache, hashing, you can use them. I'll come to that. To just give you a very good understanding with the notebook, here is my notebook. Then I'll go for the Kubernetes, how it will be exactly look like. I'm just importing some of the important libraries, sentence formation, LangChain community, okay, rank. Once I have installed these things, I'm creating a raw data here. I have one runbook where it is explaining about the Kubernetes pod OOMKilled status. Source is incident runbook, team is platform, and the date. Similar way I have runbook 2 for CPU alerts and EKS nodes, incident runbook, platform, date. Similar way I have wiki, some data, source, team, and date. Like this, I have created some data and I would like to feed as a knowledge base. I would like to feed as a knowledge base. All this data should be loaded. Let it run. It is loaded. Then I would like to convert them into embeddings and I would like to store in a vector DB, in a vector store. Okay, you can run this cell. So what I'm using here, all mini LM L6V2. With this embedding, I can use to convert these things into embeddings. Your BM25 is like your keyword matcher. So it is keyword thing for the keyword searching we will be using, and vector to store your embeddings into the vector thing. Let it run. Embeddings position ID is, yeah. Now hybrid retrieval vector plus BM25. When I run this, you will get something like this. There are questions I have asked in this script. The script is, how do I fix memory issue in the pod? OOMKilled kubectl describe what happens when Airflow DAG fail with Porch SQL error. So these are the 3 questions I have asked in the test. You see here, from runbook 1 you got a score of 0.7. Okay, it is plus of 0.6 plus 0.4, your keyword plus vector similarity. Both combinationally it ranked as 0.782, which is incident runbook from the runbook 1, runbook 3 and wiki. So this is a score for this question. So these are the 3 answers it is generated. Coming to your second query. Your second query is having 0.6 and 0.4 and these 3 answers. And your query 3 same. So different scoring. So when this different scoring happen, see here, my LLM will confuse, do I have to select which one? Okay, I have the scoring, but does it fitting into the right context, the right answer or not? Okay, so here it is no model, sir. It is just directly taking your uh, hybrid retrieval with your vector and BM to keyword matcher. So there is no LLM here. So it is just kind of a control F. In our keyboard we'll do control F in any page. We search something, it will match a filter, right? Similar way we are matching the filter with vector similarities, keyword matcher and vector similarities. So these are all things. When Kubernetes pod shows OOMKilled error, first check the pod memory limit. This is from my, okay, on the basis of keyword we are doing scoring using BM25. Yes, exactly. So this is exactly, it will give it over there. It will never shape your answer. It will never create any new generations. It will directly give the exact thing. But for your question, it is just matching the keywords. BM25 is a keyword matchup. These are all embeddings, the vectors, the cosine similarities, those it will calculate them, it will join them and you'll get this score. And you will get this score actually. So based on this, it is giving you the answer. And one more thing is called cross encoder style. So when I run this one, I'll get similar kind of answers, but the difference is here we are doing with the cohere re-ranking, which is BGE re-ranker, so this is having a different scoring. So like this we will do benchmarking not only with a one, we will use two or three different alternatives and we will check the answer whether it is properly giving it or not. So here one more thing I am adding is re-ranking. Once after this output got generated, because this is using a encoder re-ranking technique with your top k 3 top filters, the relevant top 3 files, the relevant top 3 things. With that it will do re-rank. So when it is doing re-rank, instance 001 is having 3.664, re-rank second one is having 10, re-rank score it is having 10. So which is the best one? So your context will be picking up from the your re-ranker. So this is okay, you got, but from the re-ranker you will get it. Yes, so your re-ranker will do some sort of very good filter, a more filter than your first level of filter. So based on that, your context will be able to pick up on that score, on that score. So let's say I'm matching with the top k is equal to 5, means 5 candidates. That means run book 1, run book 2, run book 3, run book 4, like that. My re-ranker will do a deeper analysis on it. Like it will look at the query, it will do some sort of indexing, then it will find the candidate chunk, then it will give you this is the relevant one. So in the re-ranking process, what it will be doing, it will it will do a calculation on positive high score. That means strong relevance of your vector similarities. Large negative score, poor relevance. So based on that, it will do re-ranking. Then it will give you this ranks. So this is the mechanism behind it will run of this re-ranking method. Okay, on this cross encoder MS Marco mini LM L6V2 re-ranker. This is a library. And coming to the RAG full guard trails. When I run this one, I have a rules here, I said, and I'm going to pass the same questions like this. A pod keeps getting OOMKilled. What should I do? Okay, what should I do? What I'm using here, LLM model, Tiny Llama 1.1b chart. So it will answer. Loading waits. Let it load. Sorry. Let it run. The second one is like RAG with evaluation with the Ragas. Ragas is a production level Python library. So we will be actually using this to how this RAG is performing in order to measure that how semantically and it is working on it. Okay, like we will be having different scores: faithful, answer relevancy, context precision, context recall. We have some values. So those values you can get it from the Ragas. Okay, it's a library, Python library. We use it at the production level. So in production, we will use different LLMs to get exact answer what we need. Yes, we use different. I use Quen, I use and Mistral. Okay, Phi, Mistral, Quen. Also Llama model. Three models I will use with the same RAG. Then I can understand which one is giving more better answer. Then you can apply some logics over there. Harness logic. Harness. Harness in LLM. Context. When your agent ticks things also, like you will be giving life cycle statement tools, guardrails, context engineering, agentic loop, all this you will give in a harness. Okay, harness is how good you are defining it, that good your model will perform. Okay, yes, Sagar, do you want to speak?
Yeah, I just wanted to check with you that so when we are using three different LLMs,
Hmm?
so how is the in the backend, like how it is calling, and how can we come out to a conclusion? Okay, this particular LLM is giving the right answer or something. So that there would be some training behind it or some logic that would be happening, right?
This is human thing actually. We is going to do a ranking on it. So it is
Okay.
not like any system. The system will say that, oh, this is good, this is bad. However, we have a metrics like perplexity, precision, context, faithfulness, all this we will do.
Mhm.
But
Mhm.
at the end, human evaluation will be there. So there are two things. You are
Okay.
doing on LLM benchmarking, means you wanted to decide one LLM is good or not. You can have one more LLM as a judge. Example, I wanted to say my base model is good or not. So above the base model, my champion model is already super good with all training data, with all score, recall, precision, everything is good. So you can use that model to decide this model whether it is good or not, because in your production model you are enforced every policies, your domain specific policies, everything you enforced over there. Then you can use that as a judge. The only thing you need to train as a judge, you need to add some other adapters as a judge. Then you can deploy that. Use that LLM to declare another LLM is doing best or not. So this is one way. Another way is you can use a rule based routings. when
Right.
when you
That
say,
is, yeah.
yeah, so when you say rule based routing, in the sense you can use if else only, if else elif, like that. That way also you can decide that whether it is good or not. Maybe there is some advanced things also following. If I have LLM1, LLM2, LLM3, my LLM1 is code, my LLM2 is chat, my LLM3 is RAG. Okay, and based on this, the best answer I will wrap it up. So by using three, you can wrap it as a one response. If you want it to be, use three, because in your company you will be building different LLMs for your HR policy, for your legal policy, maybe for your customer policy, for your chatbot, for different you will have a different LLMs. All together you wanted to work as one response. Yes, you can use them. If I have one or two and three, you have to use human or LLM as a judge. There is no other tool or any other thing. A human should be there to decide it.
Okay. Because in our project now we are using handlers and we are using this routing route
Hmm.
base and all
Hmm.
those things.
Hmm.
So yeah.
Okay. Yeah, routing is the basic thing. Uh, that is where we have to start. Then a human will be involved. That to say, because any LLM can be hallucinate. Okay, we can't relay directly one LLM say other LLM is good. We have to verify. So this is the thing, whether it is ran or not. It's still running. So Ragas, it got failed. Mm, let me run this and stop this one. We have hashing also, cache and hashing. What this cache means, today I asked a question at this time, like at time is 8:42, and next minute I have asked same question. That means my question is already being answered by my LLM. So it should not do again indexing, searching, similarity, and then you have to respond. We can avoid that by using cache. If we maintain that cache, since it is already answered me, it will easily pick up from there. instead going and doing the fresh process of going and searching from your vector. So this is a cache thing. This all will be in your pipeline. This all will be in your pipeline when your query is passing to your LLM from your backend. From your backend, after you harness whatever defined, from there, when the query is coming to your LLM, this all process will be done. And then your LLM will be having a context. Based on that context, it will give the answer. Okay. So that is the beautiness of this RAG. To give you in the real world case, how it will be deployed, I can give you three things. My LLM is a centric one. My LLM is a centric one. Okay. And I wanted to build RAG for it. I have a front end. And I have a back end. I have LLM. I have, this is vector DB. Okay. It will be going to connect to my LLM when your user is coming. Okay. And I have a pipeline here. So this is my pipeline. The pipeline is doing, it's loading data from different sources, converting. Okay, embeddings, we know that we have already discussed these things. Okay, and we'll put it into your vector. Okay, so here it will keep into the your vector. You will be having search API also. It's your wish, like you create a search API for your RAG system. So this is your call as an entire RAG system, your documents, your loading and everything. You have an APIs. It will give the context to your LLM. Okay, so this pipeline can be from your Airflow, DAGsub, or Lambda, or your Cloud Function, anything. Lambda, Cloud Function, anything. Your ETL, it's a ETL pipeline. Wherever it is possible, you can create this one. Where this vector DB will be in your Kubernetes. In your Kubernetes. So what are we planning to use out of these three? So I'm going to deploy all this, sir. Okay. So here my pipeline should work, collect the data, convert into embeddings, putting into the vector, and then load my LLM, and whatever I ask question, no, from the Kubernetes cron job I will be doing. From Kubernetes cron job. In your Kubernetes, similar way this, you have a cron job. You can create this job to work. Okay. So this cron job will do this work for me. So many companies, if you are using GKE, cron job will be there. You use jobs only, most of the cases. Okay, other than then you have the serverless things, you can use them. Load this data, convert, and keeping into the vector, and this has to use this. So let me open my VS Code. Open your Docker desktop. Okay, you must need to open your Docker desktop. Then you have a README here. Okay, just follow this README. Open preview. Not even loading. Yeah. Let me close and open. Not opening. Let me open Kira at least. Kira also not opening. You download anti-gravity. None of the ID is not opening. Oh. Yes, open now. Okay. So this is how the process will be happening. So first we have to install Docker Desktop, kind and kubectl. You have scripts already to run in your PowerShell. It will automatically build the lab for you, but you can do a manual thing here. So what I will do first, I'll maintain a bash here. Okay, I would like to create the cluster. So it will create my Kubernetes cluster. Yes, sir, I'm going there only. Here, this is a cluster one. I have a data, a very sample data, question and answers. This is a sample data I'll be going to use. And this is RAG API. So this RAG API is performing this ingesting, retrieving. This is a code. Here you can see this RAG API layer, which is nothing but FastAPI. Okay. I'm using this environment variables in order to use my RAG. Okay. And this RAG API is going to build as a Docker image. And then it will going to run as a Docker container. My RAG. Okay. So first it will perform ingestion. Then it will perform query. and document info. Then it will tell me how many chunks it loaded where into my DB. So this is RAG API, sir. Coming to the UI is just to see how it is working. Uploading the document and seeing that and how it is working. Just for UI, for our understanding. Coming to the K8s, Chroma DB is I'm using as which one? Our vector DB. Okay. So here I'm running directly with this image, sir. This image is directly available from the Docker Hub. We know that. This image is already available. No need to write any code for it. But in your real time, you will maintain a separate repository, separate Helm charts, separately you will deploy. In our lab, we are doing it just picking up the image and deploying it. But this is not the case in your real time. In your real time, you will be having a separate repository to maintain this Chroma DB or VV8 quadrant, whatever you're using. You will have a separate one. You will build the images and then you will deploy them. You will have a backup policies and all. Namespace or Llama. Here I'm running Llama container, Llama pod. Inside the Llama pod, I can deploy anything. I can Quen, Phi or Tiny model. So it's up to me to use. And RAG API. So this YML is going to run as a pod and UI. So I would be building two images and other two images I'm directly calling from the Docker Hub. Okay. Once my cluster is available, if I run this command, if I run this command, it will give me the node. Right now I have single node, that is enough. Let me, yeah. Then I would like to build a RAG Docker image because this is a path. We have a Docker file here, sir. Docker file. Build it. Build UI image as well. Similar way. If I run Docker images, I would see my images here. Okay. Yeah. Yes, I have two images. Docker API and UI. Okay. If you run this, you can able to verify them. And I would like to load because I'm not using directly any registry like ECR or all. I wanted to load these images into my cluster so that my pod will pick up them. Those images are loaded into my cluster. Then I can run this manifest file, sir. So the moment when I run, all these are going to be deployed. Yeah. kubectl, and when I run kubectl -watch, I can able to see all the pods are getting into running mode or not. One is running, which is UI. API is going to be run because it's checking liveness probe, and these containers are getting ready. 4 are running. Okay, one is creating llama, which will going to take us some time. So for this, you can download the Docker image manually because it is going to take some time, and then it will load. Okay. So right now, if you see here, I would like to pull OLlama tiny llama. Okay. So tiny llama, if I pull, I can use this. Let this run successfully. It's still creating. So meanwhile, we can check from localhost 8000. We need to export it. We need to export it. Forward. Let me run in this shell. It's exporting here. Okay. Taking more time. Oh, I think not the 8000. It's RAG API and the UI is this one. Sorry. Now this is the UI. Checking that llama is unreachable, model is tiny llama, and API is okay, and chroma is okay. This is health check. To give you a visual understanding, this is how the pipeline will work. We will not see this visually in your real world. Yes, there is monitoring things there. You can monitor them with your LangChain, LangFuse, okay, Eldama disk. With them, you can monitor them. To make you a good understanding here, let this llama load. Still creating container, yeah. Just give me one more minute to it. Ah, yes, now it is running. You can see it is running because it's going to download 1 GB, right? It will take some time. It will take some time. Here it is showing okay. It is showing okay. Now drop any PDF or TXT, or you can ask, you paste any knowledge base if you have any specific things that will inject into your your vector DB by converting as an embeddings, and we can see how many chunks it is. I would like to load a document. See the same document in the same. Load this. I have some question and answers. What is MLOps? Okay. What is ML pipeline? Training involves model registry, something like this. I would like to open. I have opened, you can see, and I would like to ingest it. Now it is ingesting. That means the pipeline is running, embeddings, converting, chunkings, those things. So we can see local 8000 / API / collections. Not found. Here you can see, I'll show that your ingested this document is 69 chunks. It says 69 chunks. Now I can ask any question. What stages ML pipeline contains? Oh my god. I think we need to give some time to it. Not loading. We need to pull this one into my llama. I'm created llama pod, but inside that no model is running.
Rajani, I think that is what is important. Sometimes, we need to know why we are doing certain things. So if you can update your notes, with why we have to do that, then that would be really helpful. Because we may remember it now, but after a few days, and maybe we will not know why we are doing it. So if it is in the notes, it would be helpful.
See, that's why I'm adding here a tip like this. So tip is like, see, 1 GB is there. So previously it was taking long time, right? Instead
Yeah.
that long time, sometime it failed, you can pull manually first in your local. So this is what happens at the real time. You will pull this llama model first and you will test it and you will keep it in somewhere in your registry already. Those images only you will load it, not the fresh new images every time. The image
Okay.
is already present whenever you go for a llama. Now it is successful actually. Okay. Now if I run this command, the list of llama, so here 42 seconds ago it is 637 MB, it's there. If I go here and ask the same question, maybe it will go and give me answer.
Hi, Rajni. So,
Yes, sir.
could you please explain these bots, these YAML files, and how these YAML files are how these bots are related, like how one service is related to another, and how we pass one service to another pod service. So that we can correlate the things how things are getting deployed.
Yes, sir. So there is only one service internally. We are not doing any external communication. So whenever we deploy ChromaDB in the real world case, we deploy it as a stateful set. But here we deploy it as a deployment. This pod and this one all will communicate by using your cluster IP only, sir. Internally. If I go here,
Hmm.
it's a I'm deploying it as a persistence volume and I'm using deployment for my chroma. And if
No,
I come down,
Yeah, one question, Rajni. Could you please scroll up? I will take 2-3 minutes.
no
Here
problem.
we are creating one persistent volume, right?
Hmm.
And that persistent volume we are adding in our ChromaDB, right? The persistent volume name is ChromaDB data, and we are adding that persistent volume there. Okay, fine.
Hmm.
Okay.
Rag lab. Rag
Hmm.
lab is the namespace. Okay, this is for Olama model and this one. Why these volumes are for our data storage? Because if my pod get restarted, recreated, it has to pick up the same data. That's why we're using this PVPVC. Sir.
Yes, but in real time, like we need to use some other database, right? Or
In
this
real,
PV.
sorry, sir. Continue.
Yeah, in real time, like do we need to use some database or this persistent volume will enough? Because
No,
it's a vector data and 2 GB. Okay.
no, not enough, sir. PVC is not enough. What we use storage class, S3
Hmm.
bucket. We use the S3 bucket. It's object storage we use like Minayo if you are open source, otherwise GCS, blob storage, or S3. S3 we will use as a backup, sir, not PVC. PVC is not enough. It will crash.
Hmm. Okay, so fine. So we are adding this persistent volume to our Chroma DB.
Hmm.
Okay, fine. And could you please explain next YAML?
Yeah. So this is a
This
namespace,
name,
sir.
yeah,
Yeah.
it's fine. Yeah.
Now this is a
Olamai. Yeah.
Llama model. I'm directly taking the image from the Docker Hub. I'm giving some limits and resources to it and a volume to it. And I'm exposing on this service, sir. So service service chroma on this port number, Olama on this port number, rag on this port number, and UI on this port number.
Correct. Okay, fine.
All are communicating on this services, sir.
Fine. And then RAG API YAML.
Yeah. So here you can see, sir, I have a config map for this service. How my
Okay,
RAG API know that, hey, there is something deployed for me.
correct.
ChromaDB is there for me. Llama is there for me. How this RAG will know? Here
Mm.
in config maps, I pass this information, sir.
Like environment variable. Yeah.
Right. So that this pod will communicate internally in the cluster to those pods.
Yeah. And in code, I think we have used os.getenv
Yes.
in main.
In the first, yeah.
Yeah, correct.
Yeah.
Got it.
So these
Got it.
values will pick up from here, sir.
Mm,
Here.
mm,
Sometimes if you wrongly updated, your pod will get into the crash loop back off issue clearly.
mm, mm. Okay, fine. Got it, Rajni. So are we planning to deploy it on cloud? Like it's our kind server, right? Kind
Yes.
cluster we have deployed.
So deploying it is similar, sir. Same kind cluster I've created, I have to create in the EKS cluster. Same process I will be following over there. The only thing, instead of PVC, I might add S3. That is the only difference, sir. There is no big difference. But deploying over there, we have to manage IAM policies, permissions, rules. Those things we have to manage in the AWS cloud. Other than that, everything is same.
Yes. So that's interesting, right? Like how to do all those things on cloud. So,
Okay. Yeah,
mm,
I have to build again that, sir, because each policy we have to create for node to access S3 and role and policy. Then I have to create an OIDC connection. OIDC means IRSA rule. IRSA rule has to be connected from my nodes to the S3 so that the backup cron job, whatever we created here, it will. Similar way, ingestion cron job also we have to do like that, sir. Uh,
okay. And we were talking about the cron job in Kubernetes
hmm,
right, to get the data.
yeah. So your RAG will do as part of your cron job, sir. Here, ingest py. Ingest py will ingest that whatever I uploaded over there. and that will, you can see nn-nn. So it is going to convert into the chunks, like size is 500, 0 to 500 the size is, and 50 is overlap, and it will split them and it will calculate the chunks. This is the ingest thing, sir. Since we are loading manually, the data I have uploaded manually, I have covered with the Python only. So for ingesting pipeline, no cron job here, nothing. But in your real time, you can use cron job to ingest that from your GCS, from your S3, from your Snowflake, from whatever the service you are using as a data storage.
Mm-hmm.
From there, your
Okay.
cron job will pick up, it will process, and it will move it to your vector DB.
Okay, Rajni. So yeah,
Yeah.
so cloud side, if we see that will be helpful because in a company like this will consider just as a POC, right, on my local. So
Okay, I understand, sir.
yeah,
So in the cloud side, it will take a more time to build that lab, sir. So maybe we have to sit for 5 hours at least, EKS building the same. We can do Lambda. We can create a Lambda function. It will take that and directly put it into your DB. So for now, I'll plan for that as well, sir. I'll take this as an input. I'll plan for that as well.
or we can do step by step, right? Like for example, one data ingestion pipeline. So uh,
Hmm.
that will complete first, and then like data ingestion means getting the data from
Hmm.
outside,
Hmm.
then putting data into vector DB, second pipeline. Then in
Hmm.
this way, small project we can do, right?
Yeah,
So
yeah, sure,
yeah,
sir. So
yeah.
what I can plan then, create an EKS cluster. On top of the EKS cluster, maybe the pipeline can be Airflow for data collection or injection, and that will write into a DB. DB I can deploy in the EKS cluster. Okay, and we will use S3 for our any other storages there. Okay, sir.
Yeah,
Like this.
yeah. I actually side with Abhishek as well in there because yeah, we need to know exactly what we do in production rather than what we do in class as well. So it would be really good, if you do. Yeah.
Okay. So then we'll plan for on the EKS, sir. An EKS we will
Yeah.
deploy.
Okay, let's plan
Uh,
something on the real time, Rajini, on the weekend. So 3 hour, whatever the numbers, right? So it's everyone can plan it one
okay,
weekend.
okay, okay.
We can use Databricks. That will be actually great if possible.
Oh, Databricks again, the workspace I'm not having right now. So we can utilize Airflow or DAGSUP. Airflow will be very good. Run in a cluster, enterprise level. Use this ETL pipeline with the Airflow DAG and write into the DB. So the DB should be in your EKS. Okay, sir. Here, if I go here, it got answered my question actually. So these are all the three things it framed my answer. On these three relevant answers, it framed my answer. Okay. So instead
These
this,
things, the chunks that it used, or
yes,
okay.
3. It is calculating vector plus BM25 on keyword matcher plus vector similarities. Based on this re-ranking, on top of these three rankings, it framed this one, sir. Okay. So how it is analyzing that question, can you summarize the context, describe and steps involving in creating ML pipeline? What I have asked, something. It is assumed this one and answer it is giving, without MLOps, organization will face last mile problem where models that perform well in notebooks fail in production due to data drift, infrastructure issues, lack of monitoring, something like this. Maybe this answer is not good, or I can go with the another model, sir. Another model,
That's what I was about to say. The answer to that question is not correct, isn't it?
yeah. So we have a fee. Like you just add the environment variable. That's it. You can load with the fee. This one, sir. Now I can download fee model into the pod.
Rajan, can you go to the UI RAG UI once? Yeah, here actually you can see like it is telling like 69 chunks, right?
Hmm.
But in the system status, it is showing a 0 chunks stored. So why
Here,
it is?
it is
Yeah, yeah.
not updating. It's a code problem.
Oh, okay, okay, got it.
It's
Oh,
a this.
oh,
It's just a
oh.
normal
Yeah,
HTML
yeah.
code
Got it, got it. Oh, thanks. Yeah.
generated by AI only. So
Okay,
it's not having that many functionality. Just to give you visualization, I built this
got it,
UI.
got it, got it. Yeah, thanks.
Yeah. So VS Code. Yeah. It's loading, which is 1.6 GB.
So Rajat, you are deploying one more LLM?
Yeah.
Yeah. Okay. So Rajat, one more question on this RAG and vector DB, right? So mostly like you are using a Chroma DB, right? Assume instead of Chroma, if we wanted to use um, VV8 database, right? So
Hmm.
do we use the same configuration as
Same.
well
Same.
for?
Same. Sir. Same. Same. Milius. Milius same. VV8 quadrant and
But
this Pinecone also.
but why it's same, right? Because that's another cloud, right? But this one is on-prem, right? So on-prem you need more. I don't know. Just I'm asking you a question, right? So VV8 and
Ah,
Chroma is on-prem and VV8.
it's like on cloud,
Um,
sir. I was saying that the number of alternatives, whatever you have
mm,
on cloud systems, you can integrate with your cloud systems. Okay. Even RAGs also. We have vector AI search RAG and Azure also having native RAG. AWS also having native RAG like open source something.
mm,
So we can use directly them instead of building this kind of RAG system also. That is also services available from the cloud native side. Here, any
okay.
open source like Milius, CNCF thing, or your Pinecone, Chroma, FSI, anything that you're using, this is a way to deploy, sir. This DBs should not be in a one single server. It should be in a Kubernetes only. Sir, memory, whatever you're planning, we can run them as Redis here, sir. Example, you can take Redis. We can run Redis here itself, sir. It
So on the
loaded.
VB database, right?
Hmm,
Sorry, the same question only. Still, I'm not clear on that part. So for Chroma, I got that, right? So you
hmm,
need to install one system, then you do all the things, right? Because it's on-prem, right? So
hmm,
let's say for VBA database, right? That's a cloud, right? So
hmm.
basically, we have to deploy that VBA database in the Kubernetes, or we have to pay the subscription fees for the compute to to the vendor VBA company.
Sir, whenever you say any service was a cloud or some vendor
Mm,
is providing to you, there are
mm.
two things where client you can deploy it and you can manage on your managed service like that, or you can pay subscription, get service available from them. Okay. So what happens in the case of your VV8? VV8 was a enterprise thing, like your cloud
Mm,
side vendor. So you have to pay
mm,
them and use them like S3. How I'm using S3, how I'm using other GCS services.
right.
Similar way, we will pay them and we'll use them. To connect
Okay.
that, we will
So
develop
basically
our
here there
client
are two
system.
charges.
Hmm.
Okay. So here there are two charges, right? One, they'll take care of the compute, just we have to pay for it. And then
Hmm.
another one is the tokens, right? That we have to pay for that.
Yes,
Uh,
exactly.
if it is enterprise level license. Okay.
Rajni, can I
Okay.
add one thing?
Yeah.
So this VV8 image is also available. So we can use Docker image to run this VV8 as a service.
Right,
Mm.
sir. That is an open source. If I
Yes.
go to
Yeah.
Docker Hub,
Like we did Chroma DB, we
hmm,
can run VV8 also.
Maybe
here,
it's not the open source, right? We have to pay for it, right? Is it
sir. But
for
see,
practice? Huh?
thing is GPTs is not open source, right? But GPT
Uh,
OSS is an open source. See, here we have the images, sir. You can see. So, but this is not verified or any of this tag is not having here. We need to only take these tags are there. Official or verified publisher or OSS. These things on. Sorry, how many? Sorry, there is a Light LLM. Sir, anyone heard the news about Light LLM? Light LLM was a very big vulnerability issue. If any of your company is using this services, please raise this concern in your company. It's compromising your sensitive information. This library is not at all good. So similar way, because this is not verified or verified whatever, there are this many downloads are there and using multiple people. Similar way, if I use any of this, there might be a injections in it which can compromise our system. So that's why on every image we will be running a scanning. On every library we will run a trivia or sneak scanning, and then we will use it themselves. So for why people will go like this on open source, at least it has to from the verified publisher like CNCF or cloud native. From there, if they are doing, then okay, because they do some sort of scanning. Even we will also do some sort of scanning and then we will deploy in our organization. Sir, I'll quickly do this one, sir, because 9:30 I have to join on call. So I have updated environment variables. Now the same question if I ask, or it will, the answer is from my fee. Okay, Abhishek sir is giving some link, production ready container. This is I don't know, sir. Is this the right website? I think this is generated by any chat GPT or Gemini, sir. They are doing some sort of crawling. With that crawling, they'll suggest, sir. Okay, got it now. Verified publisher. We can use it. We can use it. Semi technologies. They did. We can download. We can configure the same. But the thing is, we need to know about the configurations. Run in Docker desktop. Pull and run. Not enabled. Let me come here. So it is answered, you can see, sir. Artificial intelligence is a refer to the development of computer system capable of performing tasks typically require human intelligence, such as visual perception, speech recognition, from these sources. See the difference, sir, with the different models. This is how our RAG system will work with your LLM. The moment when I ask, this one also going to, and one more important thing, sir. The embedding model which we are using for in our RAG to convert the data into embeddings, the same model we have to use it question side also, sir. This side also, this side also, this side also. This side also you need to use the same model which I am using here for embeddings. Here also I need to use the same model from left side and right side. If not this one, sir, there is a distance variation will come between and your LLM will hallucinate completely. It's the biggest problem, sir. This should not be there. We have to use the same one which we are using here and the same one here also we need to use. So this is all about RAGs, sir. We have a different types of RAGs. When you started working on it, you will get to know all this what loading, chunks, hashing, and storing them. Maybe in your case, because it's a class and some sort of POC kind of demo only, we will be doing like this. But in your real time, it will take at least 3 months for you. 3 months at least. You are collecting a different data and you will decide the data points, which data points you need to consider, like PDF, tickets, text, video, images. You might be using different embeddings, not only one. You will be doing, you have images also, you have a documents to be scanned, OCR you're using, okay? You have to convert all of them into the one unit, right? In one unit or a different DBs, you want to keep it a different DBs. So when you are using different DBs, how you concisely you will connect to the one point where you have a your RAG API to search your vector and calculate your similarities. So this will only not going to be done in 3 months. If you are on the very enterprise level, like customer level or uh, legal documents, insurance, banking, lot of engineering needs are over there. RAG is not that easy that we what I'm showing right now. It will need a lot of investigation, working, experiment, and then we'll come to one conclusion. So this is what about sir, and we'll meet in the next class, sir. So can we have something like where different users are uploading some invoices, goes into the queues, and yes, sir, Kafka you can use the moment when people are uploaded any Kafka, any document, you can use a Kafka for the event, and the moment when uploaded into the front end, that will go to your S3 bucket only, and that will scan and everything, and whatever the invoice again it is generated, you can store in the S3 only, like this. So yeah, celery worker pod, like your superset, you can use them, sir.
Can we have that something like that in the real time, like in the
We can build in a project. We can build in
uh,
a project. What do we do? We'll develop a one front end, and the moment when the user is uploaded anything, we'll see the background process. The background process, where the document is going, how the document is converting, and how the another invoice document is generating. So in this process, this real time online fetching, how it is happening to your RAG, and it is adding into your vector, and your LLM response is giving to you the input data where you are storing and the output data where you are storing. You will store both the files actually. I'll tell you this.
so we'll be using that OCR technology or that document Azure Document Intelligence or something like
Yes,
that.
yes, 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 yes. Yes, please. I have to join. Just sorry. It's just an important
Yeah.
call. I'll
Thank
will
you.
will connect tomorrow.
Recording stopped.